Mr. Graham here for Clelland Maths. This is the National 5 Applications of Maths Ultimate Prelim Revision Special, going through every topic, question for question for question. You can get the PDF on my website, clellandmaths.com. Get on it and get liking and subscribing. Let's go. This video is sponsored by Lecky, and they are offering viewers of this channel 30% off of any of their books. All you have to do is use the code ClellandMaths, and the link to their books is down below. Now let's look at a couple of their books to highlight. We've got National 5 Maths and Higher Maths, and these are complete revision and practice. 2 books in one. We cover the whole course. Here's a random page, for instance, working simultaneous equations algebraically. You can see how good that book is and how clear it looks. But also at the end, practice exam papers that look exactly like the SQA exam papers that are published. Discount code ClellandMaths. Click the link to order now. SQA National 5 Applications of Maths 2023, Paper 1, Question 3. The crowd at a rugby match is made up of home, away supporters and people who are neutral. 3/5 are home, 2/5 are away. Calculate the remaining people that were neutral. So this is your standard adding fractions then taken away to get up to 1. So I need to first of all do 3/7 plus 2/5. So our common denominator is 35. That's just back times the 7 and 5 together. And obviously you can see that this one on the left has been times by 5. You can think of it as a cross. 3 5s is 15. Plus this one on the right has been times by 7. So 2 7s is 14. 15 plus 14 is 29 out of 35. So neutral is just going to be the difference between 35 and 39 to get back up to 35 out of 35. So 29, 30, 31, 32, 33, 34, 35 is 6 out of 35. And just a quick check if that's simplified. It should be, hopefully, but the only numbers that go into 6 are 2 and 3 and 6. 2 doesn't go into this number, 3 doesn't go into this number, and neither does 6. So we're done there. Question 2. Mary and John are both reading the same book, and they're using an e-book reader, and John is reading a hard book. John thinks he's read more book than Mary. Is he correct? So Mary has read 62%. John has read 210 out of 350. So let's look at John. To start with, we've got 210 out of 350, which as a percent, I can times that by 100. So if I can somehow play with this fraction and get it into a percent easily enough without using decimals, we should be good to go. So let's first of all knock off some zeros to get 1 over 35 times 100. And you should be able to see that 5 goes into 100 20 times and 5 goes into 35 7 times. But then 7 goes into 21 3 times. So I can divide by 7 to get 3 and divide by 7 to get 1. So we've just got 3 times 20 left, which is 60%. No, John has read less than Marie, as 60% is less than 62%. QE National 5 Apps 2021, Paper 1, Question 7, converting fractions to decimals. Convert 3/7 to a decimal fraction, give you an answer to 3 decimal places. 3 divided by 7 is what we need to do if you're going to convert a fraction to a decimal. So setting that up, I've got 3 to be divided by 7. I know I'm going to need some decimals, so I put a point and just put a bunch of zeros. I've put 4. Why 4? Because I'm rounding to 3, so I need an extra 1. 7 does not go into 3, so I carry my 3. 7 4s are 28. 29 30, carry 2. 7 2s are 14. An extra 6 makes 20, so carry 6. 7 8s are 56, so carry 4. 7 5s are 35. And then it's going to keep going, but I'm going to do 4 because I'm going to go down to 3. So then our final answer to 3 decimal places is 0.429 because 5 says round it up to 9. And again, take your time on this, write out your 7 times table if you're going to get stuck. Grade National 5 Applications of Maths 2019, Paper 1, Question 6. Write the following values in orders from biggest to smallest, greatest to least. Justify your answer. By justifying your answer means make them all the same so you can tell instead of just guessing, okay? So we've got decimals, fractions and percentages.
I think the easiest way to do this is to change them all to decimals. So if you try to change them all to fractions, you need to make them the same denominator. So let's have a look at our decimals. We've got 0.388 first, then we've got 3/8. So that means we've got 3 divided by 8. 8 does not go into 3. So to deal with that, I add some zeros on here. Doesn't matter how many, just a bunch, so I can keep carrying if I have to. 3 left over, 8, 16, 24, that makes 3, 6 left over. 8 5s is 40, 6 is 48, 7s is 56, 4 left over. 8 5s is 40, and then I'm done because there's no left over, so 3/8 is 0.375. Now we've got a percent, 38.38%. To change that to a decimal, we just divide by 100. 38.38 divided by 100. To divide by 100, just imagine where the point is, and it's just going to jump back. All the numbers move. So 0.3838. So now putting them in order from biggest to smallest. The biggest one I've got is 0.39 still. And then we've got 388 or 383. 388 is next. And then I've got 383 and 375. Well, that's 383 then. And then 0.375. So changing them all back to the way it was, that was 0.39. 0.388. 38.38%. And the last one was 3/8. And we're done there.
Great National 5 Applications of Maths 2023, Paper 1, Question 6. Kenny buys a new fridge, the original price was $6.50. The shop is having a sale with 20% off all fridges. It then says he goes into the shop and he gets an additional 2.5% off the sale price. How much does he pay for a fridge? Do not be tempted to take away 22.5%, 20 and 2.5. That is not what's happening here. You're getting 20% off, then you've got a new price. Then you're taking 2.5% back off. We always try and trick you with this one, especially when you don't buy carpets, so be careful with that. Let's do 20% then. So 20% of 650. Well, the easiest way to do that is find 10% by dividing by 10, so that's 650, and then double it up to 20% to get £130. So we now know we're getting £130 off. So the new price, before we get the additional bit, is 650 minus that £130. That gives me 5 minus 3 is 2, and 6 minus 1 is 5. £520 is the sale price. Now I need to take away 2.5% of that. So 2.5% of £520. Now 2.5% seems quite unwieldy with a non-calculator paper. So a couple of ways you could do this. Do 25% and divide by 10, or how I always like to think of it, find 10%, half to find 5%, half again to find 2.5%. So if I find 10% of 520, that's divided by 10, so I'm at 52. That means 5% is going to equal half of 52, which, being very careful, is 26. 2.5%, which is half again then, is 13. So that means my new price, my next new price, is 520 minus £13. You might just be able to do that without any sum here and get the answer of 507, but just in case you are doing a sum, borrow from here to get 1, and that's 10. 10 minus 3 is 7. 1 minus 1 is 0. 5 minus nothing is 5. So he pays £507. And we're done there.
It's been National 5 Application Maths 2019, Paper 2, Question 6. Denise bought 375 shares for £4.50 a share. She later sold them for £5.20 a share, and she had to pay 2.7% of the total selling price for commission. Calculate her profit. So we need to work out how much she bought them for. So looking at the bought price, we did 375 times 4.50 a share. So that's a calculator job. That gives me 1687.5, 1687.50. So that's what she bought them for. And then in terms of sold them, we've got £5 375 times £5.20. 375 times £5.20 is 1950. Normally that would be your profit, the difference between these two numbers, but she has to pay 2.75% of the selling price. So I need to work out 2.75% and take it off. So 2.7% of 1950. That gives me 52.65. So that means that her profit is simply 1950 minus 52.65, because that means that's how much she actually made, and then take away how much she sold them, bought them for originally, 1687.50. 1950 minus £52.65 minus 1687.50. That is a profit of £209.85. And we're done there. SQA, National 5 Applications of Maths 2018, Paper 1, Question 10. David sat a class test. His results are shown below. Paper 1, 35 marks. And he only got 8%. And Paper 2 was out of 65 marks and he got 60%. Calculate the number of marks achieved in Paper 1. Well, we got 80% of 35. So again, same thing I said before about percentages. Work out 10% first, or 1%, or 50%, and do a combination. So I'm going to do 10% because 8 tens is 80. So 10% is equal to 3.5 marks. So 80% is equal to 3.5 times 8. 8 fives is 40. 8 threes is 24, plus 4 is 28. He got 28 marks. Part B, calculate his overall percentage for the test. Well, we know the marks in Paper 1. We might as well work out the marks in Paper 2 and do the marks out of the total marks to get his full percentage. So his marks in Paper 2, he got 60% of 65. So 10% equals 6.5. So 60% is 6.5 times 6. 6 fives is 30. 6 sixes is 36. 37, 38, 39. So we got 39 marks. So in total, you got 39 plus 28. 67. And it's out of 65, 70. It's out of 100. So you got 67 out of 100. But out of 100 is a percent. So we got 67%. And we're done there. SQA National 5 Applications of Maths 2018, Paper 1, Question 6. Tom thinks the answer to the following calculation is 8.7. Is Tom correct? You can't just say yes or no. You need to actually work it out. And this is BIDMAS question. You've got timesies and pluses. So this is our order of operations question, which BIDMAS does help. Now, a little note on BIDMAS. A lot of people make this mistake with this question. Divide and multiply are worth the same. So if it's a divide and multiply only, you just do it in the order it's written. Same with add and subtract. They're worth the same. So once you get it to just add and subtract, you do it in the order it's written. Not the order that's here. Don't do add then subtract. Just do the order of the sum that is written. So what do I mean by that? I'm going to do my times sum first. So let's do my times, because multiply comes before add and subtract. So at the side, I need to do 4.6 times 3. 3 times 6 is 18, carry 1, put a point in. 3 fours is 12, plus 1 is 13. So my sum turns into 27.2 minus 13.8 plus 4.7. And if you were just remembering BIDMAS and thinking you need to add before subtract, you might try and add these first and then take away from there. And that would actually be wrong. There's lots of reasons why it's wrong, but the main thing for you to remember is when you've just got takeaways and adds, do it in the order it is written now. So I do 27.2 minus 13.8. So being careful with my sums, I need to borrow to get 6 and 12. 12 minus 8 is 4. 0.6 minus 3 is 3. 2 minus 1 is 1. So I've got 13.4 for my takeaway. So I add that on to 4.7. Showing all my work in, and it's helping me to do my sums. 7 plus 4 is 11, carry 1. 4, 7, 8, and I get 1. So the answer should be 18.1. So is Tom correct? Not correct. Tom not correct, all right. And there we go, we are done there. Two National 5 Applications of Maths paper 2 question 1 said a soft drinks company currently has sales of 240,000 bottles in a year. It is predicted that sales will decrease by 4.2% the next year, then increase by 5.3%. Find the predicted value after 30 years. So this is an appreciation and depreciation question, all in the one question. So the first thing is decreasing by 4.2%. So I need to do 100% minus 4.2%. And that gives me 95.8%, which as a decimal is 0.958. You just divide it by 100. Doing the same for the increase, I need to do 100% plus 5.3%, 105.3%, or 1.053. At the moment, you have got 2 marks, one for getting each of those decimals. Now to get your sum. So we've got 240,000 times 0.958 times 1.053. And now I need to check, is there any years or powers I need to add on? So it's decreased by 4.2% next year, so that's just 1. 5.3% in each of the following 2 years. So 1.053 squared. If I can get the squared and the sum, then I get a mark there. And then our final mark is just for getting the answer and rounding it. So we put it all in a calculator and you get 254937.36 and a bunch of other numbers. But we round that to 3 significant figures. So that's 1, 2, 3. We're cutting here. So that becomes 2, 5. The 4 rounds up to 5. And then I put zeros for the rest up to the point. So I've got 1, 2, 3 more numbers. And I bet I put my pound sign in to be on the safe side as well. £255,000 for our final mark.
Question 4 continued. The hotel bought a different mirror for the ballroom. The options for the mirrors are shown in the table, so you can buy some different things here: fixing, backing, glass colour, thickness, standard anti-glare, blah blah blah. Right, let's just look at what it wants. The hotel bought a mirror with an area of 3 square meters. Okay. The hotel chose the following options for the mirror, so we need to just be very careful to pick the correct options. Option 1, 4mm thick silver glass. 4mm. So let's go to our table first so we get the right thing. Glass colour and thickness is the bottom. It's 4mm. So that's bronze, that's silver. So the one we're picking is this one, 4mm silver. The next one says anti-glare glass coating. So looking for glass coating is the top, standard anti-glare. So I can highlight this is the one we've picked, anti-glare. Next bullet point, standard fixings. So looking for the fixing column, which is the second one. It's a row, sorry. Basic, standard, premium. Standard is the one we want. So I can mark that one. And the last bit is a foil backing. So backing is the third one down. No backing, foil backing. There's my foil backing here. Now, of course, it's going to ask us how much this costs. Calculate total cost of the mirror. Okay, so just need to add everything up. Taking a note of the fact that we also have an area of the mirror of 3 square meters, which we'll probably need. Let's do each bullet point in turn, or do it in order from top to bottom. It's up to you. I'm just going to do it by bullet point. So 4 millimeter thick. So we look at the price. It says price per square meter, £38. So I need to do 38 times 3 because it's 3 square meters. That gives me 114. I'll put my pound signs in at the end. Now we've got our next bullet point, which is the anti-glare. So let's look at the price of that one. Our anti-glare is £16 per square metre. So we've got 16 times 3, because it's 3 square metres. That gives me 48. Our next bullet point, standard fixings. Standard fix. So they're £32 per miller, so that's just £32. And the last one, foil backing. Well, in the table, our backing is costing £20 per miller, so that's just £20. All the answers just get added up, that's the cost of my miller. So total cost, 114 plus 48 plus 32 plus 20 equals, not even going to bother trying to add that myself. Let's get a calculator. Take full use of your calculator. £214. So put the pound sign in, 214. And we're done there. It's going National 5 Application Maths 2018 Paper 2 Question 3. Ross has changed his internet package and we've got a table below showing the packages he's considering. So this is reading information from a table. And it says he needs 52 megabytes per second, 50 gigabytes of usage at least, and a 12-month contract. Which package will we choose with the lowest overall annual price? So he needs to choose a package that gives him everything he wants. So let's check the ones he can't have first of all. He needs 52 megabytes per second. So C's out because that's 38. So that's C gone. He needs 50 gigabytes of data or usage. So A is out. And unlimited is fine. 50 gigabytes fine. He needs a 12-month contract. Well, that means E is out because that's only 24 months. So that only leaves us with B and D. So we'll work out the cost of them separately and see what one's the cheapest. So let's look at B to start with. It costs £8.95 a month and £20.99 a month with an initial fee of £59.99. So I need to add these two together and times by 12 and then add on the initial fee. So that's £8.95 plus £20.99. That gets times by 12 and then we add on the initial fee of £59.99. So £29.94 times 12 is £359.28 plus £59.99 gives us a total of £419.27. And now we'll do the same for D. So D is £7.99 a month and £18.99 a month. So take a note of that, £7.99 plus £18.99. That's still 12 months. But then the initial fee on this one is £109.99. So we need to add that on. £7.99 plus £18.99 is £26.98. You can take a note of that if you want, or since I've used brackets, I can just press times 12. That gives me £323.76. And then add on the initial fee of £109.99. Then we get a grand total of £433.75. So which one will he choose? He will choose B, as 419.27 is less than 433.75.
Five. He decides to use a payment plan. The total cost of the TV using the payment plan is $845.80, and the payments are as follows: 1/5 of the advertised price, 8 monthly instalments, and a final payment of £100. We have to calculate the monthly instalment. Let's do each bullet point in turn. First, part 1, 1/5 of the advertised price, so of 825. So 825 divided by 5. 5 and 8 goes 1 with 3 left over. 5 6s is 30 with 2 left over. 5 5s is 25. The deposit is 165 for our mark. So bullet point 2, we've got 845.80 as the full price for the instalment plan. We're taking off the 165, but we've just worked out as a deposit. But remember, we've also got a final payment of 100, so that's 265 to take off to work out the monthly payments. So that gives me 80 here. 5 minus 5 is 0. Borrow to make 7 and 14. 14 minus 6 is 8. 7 minus 2 is 5. So it's £580.80 left over, and I need to then divide that by 8. 8 7s is 56, leaving 2 left over. 8 2s is 16, leaving 4 left over. 8 6s is 48, and then we've got 0. So the monthly instalment is £72.60, and we're done there.
6. Continue. Lorna visited Switzerland and decided to buy some cheese. The cost of 5 types of cheese is shown on the table, and it's 250 grams, Swiss francs. Okay, so she got 3 different deals for buying the cheese. Best buy question here. Lorna's going to buy 250 grams of each cheese. Use working. Determine the best deal for buying all 5 cheeses. Use your working to justify your answer. So, 5 out of here, 5 out of here, or 5 out of here. And she's going to buy 250 grams of each cheese. Right. So I did 250 grams. So we just need to now just use these prices with each deal. So just do it bit by bit. Let's do deal A. You buy all 5 for 1850 francs. Okay, so that's just 1850. There's no sum. Don't overly complicate things. It's not saying 1850 each or anything, just 1850. So we've given us that one. So part B says buy all 5 and get the cheapest free. Okay, so all 5. You get the cheapest free, which is this one. So we just don't add them together. So we just need to add these 4 numbers. So £2, 2.50 plus 7.50 plus 7 plus 3, because the other one's 3 anyway. So 750, 8, 950, 20. It's going to be 20 in total, 20 francs. Use your calculator if you have to at any point. Part C, buy all 5 and save 15%. Okay, so I need to buy all 5. £2.50. It's not pounds, it's francs. 7.50. 7, 3, and 2. Well, I've already worked out the previous was 20, so that's 22 francs. You save 15%, so you get 15% off. So there's 2 ways to do that. Since we're on a calculator paper, take away 15% to get 85% and times by 0.85, or work out 15% and take it away. I'll do it the first way because it's quicker. So if you're going to save 15%, that means you're going to pay for 85%. So 0.85 times 22. No way I'm doing that without a calculator. 18.70. Determine the best deal. So we started off with 1850. B was 20 and C is 1870. Let's just highlight the ones there. Therefore, deal A is the cheapest and therefore the best buy. Deal A is best as it's the cheapest. You could then say, to be over egging this, 18.50 is less than 20 and 18.70. Let's just leave. National 5 Applications of Maths 2023 Paper 1 Question 4. Jeffrey shared his savings between his 3 children, Sophie, Ed and Lucy. The money was shared in the ratio of 7 to 2 to 6. It says Sophie received £3,304. How much did Jeffrey give his 2 children? How much did Jeffrey give his 3 children in total? So there's a ratio of 7 to 6. That's Sophie. Suppose that's Ed and Lucy. And we know that Sophie's share was 3304. And her share is worth 7 parts, so I need to divide by 7 to get 1 part, and then I can times by either the whole total, or I can find Ed's and Lucy's and then just add it all together. But let's just find 1 part first. So 1 part is equal to 3304 divided by 7. Now, if you don't know your 7 times table, just take a quick note of it at the side, but I do, so I'm just not going to do that. 7 times 4 is 28. 29, 30, 31, 32, 33 gives me 5 left over. 7 sevens is 49, leaving 1. 7 twos is 14. So 1 part is equal to £472. So then I could either times by 2 and times by 6 and add it all together, or I could realise that I've got 7, 8, 9, 15 parts in total, so I could just times this number by 15, which is what I'm going to do. But either option is working for you. So total parts is equal to 7 plus 2 plus 6, which is 15. So total amount, I need to do 15 times 472. So let me just set up a normal sum like this. Or you could times by 10 and times by 5 and add it together. Or times by 10 and half it and add it together. There's lots of options here, but I'll just do a standard sum. 5 twos is 10, carry 1. 5 sevens is 35, plus 1 is 36. 5 fours is 20, plus 3 is 23. And then 10, so it's 1 times 2, 1 times 7, 1 times 4. Carefully adding these together, I get 0. 6 and 2 is 8. 7 and 3 is 10, carry 1. 4, 5, 6, 7. So the total amount is equal to, with a pound sign, £7,080. And we're done there. Bar charts and the ratio. SQA National 5 Apps 2021 Paper 1 Question 8. The bar chart below shows the medals won by 4 countries in the 2016 Olympic Games. So we've got gold, silver, bronze shown on the bars by these different shadings, I suppose. And part A says calculate the number of medals won by the UK in the 2016 Games. So the number of gold medals, sorry. So 2016 Games for UK is here. I need the gold. So we're starting at 40. We need to know what it's going up in. So we've got 1, 2, 3, 4, 5 divisions. So it's going up in 2s. So 1, 6, 40. That's 10, 20, 22, 24, 26. In the middle makes 27. So we can just write 27 for our answer to that one. Part B says calculate the ratio of gold to silver to bronze medals for France. So we need to know France's gold, silver, bronze. So let's do our gold first for France. We have got 30, 32 on, so that's 2, 4, 6, 8, 10 for the first number. So I'll just note these as I go. We've got 10, 2, the silver, 2, 4, 6, 8, 10, 12, 14, 16, 18, 18. And the last one, 2, 4, 6, 8, 10, 12, 14. So initially we get 10 to 18 to 14. So then we need to simplify that. So we need to find a number that goes into all 3 of them. I can see they're all even, so I'll just half them. So that gives me 5, 9, and 7. And there, I can't simplify that anymore. So I'm done there. SQA National 5 Application of Maths 2022 Paper 2 Question 7 says, Part A, Jamal keeps fish. To make tap water safe for fish, a condition is added. The volume of condition required is directly proportional to the volume of tap water. 5 mils of condition is used for every 20,000 millilitres of tap water. Calculate the volume condition for 14 litres. So we know that 5 millilitres is used for 20,000 millilitres of water. And that's conditioner. I'll just write conditioner. What's the volume for 14 litres? So let's do 1 litre, divide by 20, so 5 divided by 20, 5 millilitres. And then we can go to 14 litres by timesing by 14. To get 3.5 millilitres.
for our final.
Okay, proportion. SQA National 5 Application of Maths 2021, Paper 1, Question 14. A 240 gram steak costs £3.84, complete with label shelf to show the price per kilogram. So 240 grams is equal to £3.84. And I want to get up to 1 kilogram eventually. So we know 240 grams is equal to £3.84. And we want to know what 1,000 grams is. So you can either go down to 1 gram, you can always do that each time, or you can do a bit of clever maths to get there. It's up to you. What I'm going to do actually is get as close to a kilo as I can. So if I times both this by 4, that gives me 960 grams. So I'll know the price of 960 grams by timesing this by 4. 4 fours is 16, 4 eights is 32, plus 1 is 33, 4 threes is 12, 13, 14, 15. So that'll take me to £15.36. But I'm short by 40 grams. So I need to know the price of 40 grams. Well, if I do 240 divided by 40 grams, that's knocking the zeros off, gives me 6. 40 goes into 246 times. So that means I can know that 40 grams is also equal to £3.84 divided by 6. Six fives are 36, 6 is 36, carry 2, 6 fours is 24. So I now know 40 grams is equal to £0.64. So that means that 1 kilogram just equals £15.36 plus 0.64, which is 0.060 or £16. And we're done there. Garden. It normally takes a team of 4 workers 12 hours to complete the task. The company sent an additional worker to help complete the task. All the workers work at the same rate. We started at 8, took a 30-minute break for lunch. What time did they finish installing the hot tub? Okay, so this is reverse proportion, inverse proportion. Okay, so you think if you're doing work, the more people that do the work, the less time it takes. So 4 workers usually take 12 hours. So to do 1 worker, well, if this was me baking a cake, I would divide by 4 and it would take 3 hours. That makes no sense. 1 worker's not going to take 3 hours, not unless he's at Captain America or something, or a Flash. So it's the opposite, inverse proportion. 12 times 4. 12 times 4 hours, which equals 12, 24, 48 hours. So I now know 1 worker takes 48 hours, and it says how many workers have we got? An additional worker. So we're going to 5 workers now. So now we can divide. We know it's 48 hours for 1 worker. Divide by 5 to get a smaller number. 48 divided by 5. I'm going to get a feeling this is a decimal. 9.6 hours. The usual with this, you get a decimal time, so you're going to have to change that decimal time into hours and minutes. So to change 9.6 hours into hours and minutes, well, we've got 9 hours, and then to get our minutes, we've got 0.6 hours, 60 minutes in an hour, so times by 60. I can do that without a calculator, but let's just do it with anyway. 0.6 times 60 is 36. So it's 36 minutes. Now to answer the question, they started at 8 and took a 30-minute break for lunch. What time did we finish? So we're starting at 0800, and then we're add the 30 minutes anytime you want, just wait to the end. Let's just add our 9 hours. 8 plus 9 is 17. So I'm going to write 1700. Not going to bother trying to change that into PM or AM. It is 5 o'clock, of course. Add my 36 minutes, and I get 1736. Then I need to add 30 minutes. Easiest way to do that is add up to the next hour first. So 36 becomes 46. 56 is 24 minutes, which leaves me an extra 6 minutes left over to get to 1806. So we finish at 1806. Just check we don't ask you for it in AM or PM. It doesn't ask, so it's fine. And they gave us it in 24-hour time anyway.
SQA National 5 Application of Maths 18, Paper 2, Question 5. 3 tons of sheep food will feed 350 sheep for 18 days. The number of sheep increases by 100. How long will the same food now last? So this is called reverse proportion. So we know that 350 sheep will be fed for 18 days. I want to work out how much 450 sheep will be fed for. So why is this inverse proportion? Well, it's either work done or it's getting fed. If you think about these sheep, if I was to say, well, how long does the food last one sheep? Clearly it lasts a lot longer. So you're not going to do 18 divided by 350 because that means that one sheep, it would only last like hours. That makes no sense. So for one sheep, since this is inverse proportion, it's 350 times 18, which is 6300 days, which means for 450 sheep, and now divide by 450, 6300 divided by 450, 14 days, which makes sense. More sheep, less days. So if you get an answer like more sheep and it lasts more days, that doesn't make sense. That means the sheep are eating less. Applications of Maths 2022, Paper 2, Question 6D. Pepe inspects the fire extinguishers of a local business. The fire extinguishers are considered safe if they weighed 10.4 kilos plus or minus 10%. The weights of the fire extinguishers inspected are shown. What's the maximum and minimum weights and determine the fraction that was safe? It's okay. So our max and our min. If we're adding 10%, we can times by 1.1, or we can just do 10% and then add it on. It's up to you. 1.1 times 10.4, or like I said, do 10% of 10.4, then add it on. That gives you a maximum of 11.44 kilograms. And then taking away 10% from 100% is 90%, so that's 0.9 times 10.4, which will give me a minimum of 9.36 kilograms. Or alternatively, like I said, do 10%, which is 1.04, and then just take that away from 10.4 to get 9.0636 and add it on to get 11.44. Now we need to work out how many are safe. So it has to go between 9.36 and 11.44. So you can just tick the ones that are okay. That one's okay. 11.67 is not okay. 9.12 is lower. 10.94 is in between. 11.10 is in between. 9.27 is too small. And 10.55 is in between. So I've got 1, 2, 3, 4 that are safe out of 1, 2, 3, 4, 5, 6, 7 in total. So it's 4/7 that are considered safe for our final mark. 1 for max, 1 for min, 1 for final. Screen answer 5, Applications of Maths 2019, Paper 1, Question 1. Helen makes and sells candles. These candles should be 22.5 centimetres tall. She rejects any candles that are out with this range plus or minus 2 millimetres of this height. Below the heights of 10 candles chosen at random, calculate the percentage that she rejects. So the first thing we need to do is find the max and the min. So the max it can be is equal to 22.5 plus 2 millimetres, so 0.2 equals 22.7 centimetres. And the min is 22.5 minus 0.2, which is 22.3 centimetres. And that's a mark there. Next step, work out which ones are rejected. So anything below 22.3 or above 22.7. So that one's rejected. 22.6 is okay. 22.5 is okay. 22.9 is too big. 22.3 is okay. 21.6 is out. 22.6 is okay. 22.4 is okay. 22.7 is okay. 22.8 is out. So 4 are rejected. So rejected, we have got 4 out of 10. And out of 10, I need to make that a percent. You should know that's 40% because it's out of 100 is percent. That's 40, just times them by 10, or 40%. And we're done there.
It's grade National 5, Application of Maths, 2023, Paper 1, Question 5. Eddie runs a stall at a school fundraiser. The game requires 2 spinners to be spun and allowed to come to rest. The spinners are shown, so we've got one spinner which is colours and one is numbers. A prize is won if one spinner lands on blue or green and the other spinner lands on an even number. Calculate the probability of not winning a prize. Well, there's lots of ways to do this, but one of the standard ways is to work out all the probabilities with a sample space diagram is what it's called, or you may just know it as a table. So on one side, I'm going to write red, green, yellow, one red again, and then we've got blue. That's our options for the first spinner. And the second spinner goes 1, 2, 3, 4, 5. Might be handy just to call that R, G, Y, R, B. So in the middle is all the chances of things happening, right? So we've got red and 1 could happen, R1, R2, red and 3, red and 4, red and 5. Or we could go green and 1, green and 2, green and 3, green and 4, green and 5. Or we could go yellow and 1, yellow 2, yellow 3, yellow 4 and yellow 5. Or we could get back in red and 1, red and 2, red and 3, red and 4, red and 5. Or we could get blue and 1, blue and 2, blue and 3, blue and 4, blue and 5. So there's all the things that can happen from getting 2 spinners. Now it says a prize is won if the spinner lands on blue or green and the other spinner lands on an even number. So let's start highlighting the winning cells. We can have blue, which is the bottom ones, and it has to be even. So 2 is a winner and 4 is a winner. It also wins if it lands on green with an even number. 2 is a winner, 4 is a winner. So we've got 1, 2, 3, 4 winners. Is that right? Blue and green. And even, well, there's only 4 winners. So how many losers is there? Well, we can either count them or use a bit of maths. We've got 5 by 5 options is 25. Take away these 4 means I've got to lose a chance of 21 out of 25 possibilities. Just double check that that is simplified. That's simplified, so we're done. With this question, there is a number of ways you could do this. Basically, you just need to calculate how many probabilities are there, what's the chances of all the things, and you need to work out how many things you don't want to happen. Now, you could have worked out how many things you did want to happen, then add up to 1 and listed them anyway, but that's one of the neatest ways to do it. National 5 Applications of Maths 2023, Paper 1, Question 8. Janet travelled by car from her home to a meeting. She arrived at the meeting at 10:15. She travelled 160 miles at an average speed of 40 miles per hour. During the journey, she stopped 50 minutes for breakfast. Determine which time Janet left home. So, we know she arrived at 10:15, so that's like way over here. That's her arrival at 10:15, say. AM. And she travelled for 136 miles at an average speed of 40 miles per hour, so we need to work out the time for that. So let's just make a note of that. We need to work out that time. But then during the dinner, she stopped 15 minutes for breakfast. So I can take away that 15 minutes to start with. So going back 50 minutes. So the easiest way to do that is take away your 15 minutes. That gets me to 10 o'clock. And then the difference, 25, 35, 45, that leaves 35 minutes off of 10 o'clock. So that's 9:30, 9:25. Let's just say she stopped there. It doesn't really matter when she did a break. So then the time, well, speed. The time, well, distance equals speed times time. Couple of ways you can do this. If you can remember all your formulas, or a triangle sometimes help. The distance, speed, time triangle, where we want to work out time, so we cover it up and it says distance divided by speed, or we can just rearrange the formula. Time is distance divided by speed. Whatever way you do it, you get distance divided by speed. The distance is 136 and we're dividing by 40. You will probably have to do a sum for this then. 136 divided by 40, 40, 81. 20 is 3. decimal point time then, add some zeros, it doesn't really matter how many. I'm on 120, so I need 16 left over. Now start counting again. 40, 80, 120, 160. That goes in exactly 4 times, so I'm now on 3.4 hours, which is kind of useless to us. 0.4 of an hour, I'm going to have to change that to minutes. So 3.4 hours. So I've got 0.4 hours is equal to 0.4 times 60, because it's 60 minutes in an hour. That is 24 minutes. How did I do that so fast? Well, if I think about times them by 10, first that takes me to 4, and then it's just 6 left. 4 6 is 24. So 3.4 hours is equal to 3 hours, 24 minutes. So going back up to my little diagram, I need to take away 24 minutes. So let's take away the 24 minutes. That leaves me with 9:01 a.m. And then I need to take away the 3 hours. 9876, 01 a.m. So just to answer the question, left home at 6:01 a.m. and we're done there.
This question says the final event of the heptathlon is an 800-metre run. In this event, another of the competitors scored 1,000 points. By referring to the table, calculate this competitor's average speed over the 800-metre run. Give your answer in metres per second. So let's have a look at the table. 800-metre run, 1,000 points. So the 800-metre run is over here. We got 1,000 points, which is here. So where they cross, it took them 2 minutes and 8 seconds. So there's a key number. It tells us a time, 2 minutes, 8 seconds. So I can write the time equals 2 minutes and 8 seconds. I know the distance because it's an 800-metre run. And I have to work out the speed. Well, there's lots of ways you can memorise all your speed, distance, time equations or know one of them and rearrange it. Or one simple way is distance, speed and time. And we want to work out the speed. So if we just cover up the speed, it tells us to do distance divided by time. So speed is distance divided by time. Now we need to make sure we get this right. Our time is quoted as metres per second. So I need all this in seconds. So the first thing I need to do is change my time from 2 minutes, 8 seconds, all to seconds. So my time, working on that, well, 2 minutes is 2 times 60 seconds, which is 120. So our total time is equal to 128 seconds. So now I can do my sum, 800 metres divided by 128 seconds. Using a calculator, you get 6.25 metres . Maths 2021, paper 2, question 6 continued. At the weekend, Finley plans to make a return journey from his home to the shopping centre. It's 26 miles away, it will cover 67 kilometres per gallon, and he has 5 litres of fuel in his tank. Determine if Finley has enough fuel to complete his return journey. And it gives us 2 bits of information. 1 mile is 1.609 kilometres, and a gallon is 4.545 litres. So we know how much gallons, how far he travels per gallon of fuel. So I need to know how much gallons he has. So I've got 5 litres. And we know that 1 gallon equals 4.54 litres. So 5 litres divided by 4.545 will tell me how many gallons he has. That gives me 1.1 gallons. Let's just keep a note of that. Now we get 67 kilometres per gallon. So how far he can travel must be 67 times 1.1. So I've kept that number in the calculator, so I'll just times that by 67. And that gives me 73.707. Let's just call that 73.707
73.707 kilometers. So I know he can travel 73.707 kilometers, but it says the shopping centre is 26 miles away. So I need to know what that is in kilometers, or I can change the kilometers into miles. I'll change the kilometers into miles. So it says 1 mile is 1.609 kilometers. So if 1 mile is that, 73.707 kilometers equals 73.707 divided by 1.609 will tell me how many miles he can go. That gives me 45.81 miles. Now, it looks like he can do it, but it says it's a return journey. We're trying to trick us. So the shopping centre for a return is 26 times 2, which is 52 miles. So he cannot make it because he can only go for 45.81. So the answer is no, since he can only go 45.81 miles, which is less than 52 miles. And we're done there.
SQA National 5 Application of Maths, 2018, Paper 2, Question 7. Sam drives from Paris to Zurich and he knows his car will cover 47 miles per gallon of fuel and the fuel tank holds 50 litres and it's 650 kilometres from Paris to Zurich. Will we be able to complete it on a tank of fuel? So it gives us a few conversions, so we're doing some conversions here. 1 mile is 1.609 kilometres and a gallon is 4.54 litres. So we're just going to try each bullet point in turn and see if we can get anywhere with this. His car will cover 47 miles per gallon of fuel. Great. 47 miles, but I've got it in kilometres. So bullet point 1, it'll do 47. 1 mile is 1.609 kilometres. So times 1.609. And that'll tell me how many kilometres he does in a gallon. He does 75.623. Now I'm not going to round because there's going to be a lot of sums. 75.623 kilometres per gallon. Next bullet point says the fuel tank holds 50 litres of fuel when it is full. But I don't know much about that. I know gallons. I know I'm getting 75.623 kilometres per gallon. So I'm going to turn that into gallons. So I'm starting off with 50 litres. So I've done bullet point 1, bullet point 2. I'm starting off with 50 litres. I want to go backwards to gallons. So I'm going to divide by 4.545. So that's 11.0011 gallons. It now says it's 650 kilometres from Paris to Zurich, where I know I get 75.623 kilometres for every gallon, and that's how many gallons I've got. So I just times them together to see how far I get. So for bullet point 3, I'm doing 75.623 times 11.0011. That gives me 831.94 kilometres. So the answer is yes, since 831.94 kilometres is less than 650. Now there's other ways to tackle this question.
Hi, Jackie wants an item sent from her Dubai shop to her New York shop. It will be sent from her Dubai shop at 8:45 local time on the 24th of November. The expected delivery time is 90 hours. Wow. New York is 5 hours behind Edinburgh and Dubai is 4 hours ahead of Edinburgh. Determine the local time and the date the item is expected to arrive at our shop in New York. Got a big one, this one, for the end here. So, 90 hours. we need to work out how many days and hours that is. So I need to do 90 divided by 24. So that's 3.75 days. So that's 3 days. Then the 0.75 part was 24 hours in a day. So that's 18 hours. Now, she's in Dubai at 8:45 a.m. and it tells us different times for Edinburgh compared to New York and Dubai. So let's just work out this and then we'll add in the different times. Okay, so we're at 8:45. So I need to add on 18 hours. So 8 plus 18, if you just use a calculator for that, is 26. But once I hit midnight, it's a new day, okay? So it goes 8, 18, 19, 20, 21, 22, 23, 24, or 0, then 1, 2. So I'm on 2 o'clock in the morning, 45 the next day. So that was starting on the 24th of November. So I'm now on the 25th after 18 hours. I'm now going to add 3 days. 25, 26, 27, 28. So I'm now on the 28th at the same time. But this is Dubai time. Now I need to work out this strange thing of New York and Dubai. So I'm trying to get to New York. And New York is 5 hours behind Edinburgh. Dubai is 4 hours ahead of Edinburgh. So changing to Edinburgh time. I'm on 02:45 on the 28th. And Dubai is 4 hours ahead of Edinburgh. I need to take away 4 hours. Minus 4 hours. Well, that's not going to knock me back a day. That's fine. Doesn't matter. So 02:45 minus 4 hours. So that becomes 01:45, 00:45, 23, 22:45. And that will now be the 27th. So now going to New York time. It says New York is 5 hours behind Edinburgh, so I need to take away 5 hours. So that gives me 22, 21, 20, 19, 18, 17, 17:45, and I'm still on the 27th of November. And we're done there. National 5 Application to Maths 2023, Paper 2, Question 3. Fiona's having her back garden redesigned. A new fence is to put up from A to B and from B to C. Rows of fence are 3 metres long, cost £22 per row. Calculate the cost of the fencing. So A to B is here and here, so we already have that length, that's 21 metres. So let's just write that down. A to B equals 21 metres. And it wants us to go from B to C, which is from here to here. You'll notice you've got 2 right-angled triangles. So I can do Pythagoras twice, essentially. If I do Pythagoras here, that'll give me this length. And then Pythagoras with these 2 to get this length. So for clarity, let's call that 1 and 2. So Pythagoras on 1, let's call this little length here just x for the sake of it. 5 squared plus 7 squared is equal to x squared. 5 squared plus 7 squared is a calculator job. 74. So x squared is equal to 74. Now you could just leave that as x squared because you're going to actually square it again when you do the 21 squared before you square root. But I'm assuming a lot of you are going to square root here. So I'm going to find x as the square root of 74, which is equal to 8.6023. But you could have just left it as 74 for x squared, because now what we're going to do is Pythagoras on shape 2. So for shape 2, just being very careful, This is the hypotenuse across opposite right angles, also hypotenuse. So if I call this side, say, let's call it y, then this squared and this squared I have to take away because I've already got the longest side. So that means that y squared equals 21 squared minus the answer we just got squared. So that equals, getting a calculator, 21 squared minus this answer squared, which is 74, because it's the square root of 74 we had, or just put it in again, is equal to 367. So y is the square root of 367, 19.157 or 19.16. I'll just put that as 19.16. And that's meters. So now we've got both our lengths. We've got 21 from A to B and 19.16 from B to C. So total length (21 plus 19.16) is 40.16. Now it also tells us some information in the question. It tells us that rows of fencing are 3 meters long and cost £22 per row. So I now need to work out, well, how many rows I need to buy. So number of rows is equal to our answer of 40.16 divided by 3 because they're 3 meters long. So taking that in our calculator, we get 13.38 with a bunch of other numbers. But that means we need to buy 14 because otherwise we'll be short. So we're buying 14 rows. And then the last bit, they cost £22 per row. So the cost is equal to 14 times 22. And we get £308. And we're done. To right-angled triangles. As shown in the diagram, calculate the total length of cable needed for this section of the bridge. So I need to work out this length cable and I need to work out add on that one. Now to get this one I need a right angled triangle to do Pythagoras, but I'm going to need the height. I don't have it, but I can use this triangle first. So let's call this bit A. Then A squared equals 300 squared minus 295 squared, because Pythagoras, opposite a right angle, is the longest side. So when I've got the longest side, I take away. That gives me 2975. Square root of 2975 is 54.54. So that means A equals 54.54. That's our height. And that's in meters. So now we've got the other triangle, which is on the left. And that is 54.54. And that is 600. So if we call this one C, then 54.54 squared plus 600 squared equals C squared. So this is now an adding Pythagoras because I'm finding the longest side. We already know that that squared is 2975 plus 600 squared gives me 362,975. So C is the square root of that number. And that is 602.474. So now total length of the table is just that 602.474. So we do 602.474 plus the 300, 902.474, let's just call it 47 to 2 decimal places and be done there. SQA National 5 Applications to Maths 2023, Paper 1, Question 9. The design of a skate park ramp is shown. The height is 70 centimetres. To be suitable, the ramp must have a gradient of 0.35 plus or minus 0.01. Determine whether the ramp is suitable. So you work out the gradient. The gradient is vertical over horizontal. Our vertical is 70 centimeters, but our horizontal is 2.1 meters. So we're going to have to make it all the same units. So I'll keep it all in centimeters to have bigger numbers. That's 70 over 210 centimeters. So simplifying that, that gives me 7 out of 21. And simplify that again, because 7 goes out of 21 3 times, that's a third. Change a third to a decimal. You should maybe already know a third is 0.333, but if you don't, you can quickly do a wee sum. 1 divided by 3, 3 doesn't go into 1, so add some zeros. 3 3s are 9, add 1, 3 3s are 9, add 1. You should be able to see that it just goes 0.333 forever. And now it says determine if the ramp is suitable. So we've got this tolerance here. So our max, it can be is 0.35 plus 0.01, which is 0.36, and our min is equal to 0.35 minus 0.01, which is 0.34. So the ramp has to have a gradient between 0.34 and 0.36. So is it suitable? Not suitable, because 0.33 is less than the min of 0.34. And we're done there. Maths 2019, paper 2, question 10. A sports ground is the shape of a rectangle and 2 semicircles is shown. Running track is shaded in the diagram. Calculate the area of the running track. So if we look at this one here, we could do the area of the whole thing minus the area of the whole. Or what we could do instead is just do our circle part minus this circle and then just add on the 2 rectangles. And that's the approach that I'm going to take here. So let's look at our circles. We've got 1 semicircle on this side and 1 on that side. So in total, we've got 2 whole circles, a big circle and a small circle. So I'll do the big one minus the small one. From the start of the exam paper, the area of a circle is pi r squared. So I'm going to need the radius. So let's get a calculator and work out the radius of the big one. So the radius for this one is going to be half of that. 90.7 divided by 2 is 45.35. And then for the middle bit, I've got 73.6 divided by 2, which is 36.8. So in this bit, I could write 36.8 meters for both of them. So then it's just the area of the big circle minus the area of the small circle. So that's pi times 45.35 squared minus pi times 36.8 squared. Now, we could do these sums separately and then get our answer, or we can just do brackets around them both. So I'm just going to do brackets just to quicken this up. So getting my calculator, bracket pi times 45.35 squared, close my bracket, minus bracket pi times 36.8 squared, close the bracket, press equals, and you get 2206.599. 2206.5997 meters squared. So that's my circular bit done. So now I need to do my rectangles. So for my rectangles, I've got this length times this length. And I've got 2 of these rectangles. So I need to identify the length and the height. So to get the height, you've got all the way up minus this bit, but then I need to divide by 2 because there's 2 sides of this. So 90.7 minus 73.6 divided by 2 is the height of each rectangle. and that gives me 8.55. So now for my rectangle, I've got 8.55 here, and I've got 84.4 here. So the area of that is 84.4 times 8.55, but I've got two of them, so times 2. 1443.24. So I've now got two areas. I've got the area of the circular parts. I've already took away the holes, and I've got the area of the grey rectangle, so I can just add them together to get my final area. So total equals 2206.5997 plus 1443.24. That gives me 3649.839, or 3649.84 would be fine. 3649.84 meters squared. And there's our final answer there. Integrated National 5 application maths for 18, paper 1, question 13. A lawn is to be created in the shape of an isosceles triangle with the dimensions shown. Calculate the area. So the area of a triangle is a half the base times the height, but we have not got the height. But it is isosceles, so if I do that, I'll cut it in half here, which means I can work out the height with Pythagoras. So it's a Pythagoras question. So let me just draw that in. Cutting that here. So that means that this is 6 meters, and we've got 10 meters. So showing you that on a normal triangle outside here, we have got 6 and we've got 10, and we're working out this side here. Let's call it x. Pythagoras says a squared plus b squared equals c squared. That's when you're finding the long side, that's a and b, and that would be usually c. But I'm finding the short sider, so that means that I take away. So that means that x squared, because I've called it x, you can call it a or b if you want, equals 10 squared minus 6 squared. That's 100 minus 36, which is 64. Square root the answer, so x is square root 64, which is 8 meters. So I now know the height is 8 meters. Area is half the base times the height. The base is 12 and the height is 8. So that's a half times 12 times 8. Half of 12 is 6. So I do 6 times 8. 48 meters squared. Use square units for area, and we're done there. National 5 application of maths 2023 paper 2 question 2. A glazier is edging the perimeter of a window. The window is in the shape of 2 rectangles and 2 identical quarter circles. Calculate the length of edging required for the perimeter. So perimeter is all the way around the outside, so I'm going to have to go 100 plus 2,300 plus another 100, but then it's this arc length here. So you will recall from the start of the exam paper that the circumference of a circle is pi times the diameter. And we have got 2 quarters of a circle, so we work out a quarter and then just double our answer. So for a quarter circle, we have 1/4 times pi times the diameter. Now be very careful here. This is the radius, so the diameter is double this, which is 1,400. Get a calculator out and work that out, but then double it. 1/4 times pi times 1,400, which is 1099.557. So for both quarters, that's 2 times 1099.557. I'll just leave it in my calculator and times by 2. I get 115.1148. I'll just put ... rather than rounding. So there we go. We've done our circles. So our perimeter is just going to be equal to the answer we just got, 2199.1148 plus, and then we've got 1,000, 2,300, another 1,000. So I'll just write that as I go. 1,000, 2,300, plus another 1,000, plus, now let's be careful with this, I missed it almost. Notice this goes down, along, up, curves, then you've got this bit in the middle. So how big's this bit in the middle? Let's just work that out. Well, I've got 700 to here and 700 to here. We know that's 1,400. So this bit in the middle is 2,300 minus 1,400. If you need, you can use your calculator at any time, but that is 900. So that extra bit is 900. So we need to add on 900 as well. 2199.1148. No need to round, I'm going to round it in anyway. Plus 1,000. Can't really see that. Plus 2,300. Plus, I think it's another 1,000. Plus a 900. That gives me a grand total of 7,399.1148. Put my dots in because remember I didn't round. But if you did want to round, it doesn't ask you to round. A couple of significant figures would be appropriate. So about, I can put that as 7,400 millimeters, I think would be fine. But any reasonable rounding would be okay. Lorna also purchased a paperweight as a gift. The paperweight is in the shape of a cube with a hemisphere on top. A hemisphere is half a sphere, of course, with a diameter of 6 centimeters. Calculate the volume of the paperweight. Start of exam paper does tell us that a sphere is 4/3 pi r cubed. It does not tell us a cube. We were just or a cuboid, so you need to know that yourself. Okay, so let's take a note of a sphere. We'll call it a hemisphere. That's going to be a half times 4/3 pi r cubed. Make sure you write that down right. The number of people I see writing 3/4 is ridiculous. It's 4/3 and it's cubed, not squared. Okay, right. Okay, next bit. That's our hemisphere, and then we've got our cube. Is it a cube or a cuboid? Cube. So a cube, each side is the same, and you're just doing length times breadth times height. So for a cube, length times breadth times height. So let's do each one separately. Our cube is 6 times 6 times 6. I think that's 216, but that's only because I memorised cube numbers. Let's actually put it in the calculator. 216, yep, centimetres cubed. And let's now do our hemisphere. So our radius we need to find first. Clearly the diameter 6, so the radius is half, which is 3. Always watch, we're not trying to trick you, which we were. So it's a half times 4/3 times pi times 3 cubed. What do we do that in a calculator? Well, let's see. A few ways to do fraction in a calculator. You can actually use the fraction button if you know that. I've got a feeling you don't. Or you can just divide, right? 1/2 is 1 divided by 2. So I can just put brackets 1 divided by 2 times brackets 4 divided by 3 times my pi times my 3 cubed, so a power button and then a 3, press equals, and I'll just give you the answer. 56.54866. 56.54866, blah, 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 blah. So our total volume is equal to our answer, 56.548 plus 216. Notice I'm not rounding there because I just can't be bothered. We'll round at the end, right? You should always round at the end anyway. So there's your answer. I plus the 216. I get 272.548. Not sure what your teachers told you about rounding, but technically you should never be any more accurate than the accuracy of the actual question and measurements in the question, which there's only one anyway, to one significant figure. So really you could write your answer as 300 and you should be fine. I wouldn't do it, right? Let's just make it 272.5, and that seems reasonable to me because it's not giving us any real rounding to do for this question.
Of a pool in litres. So if I want to know the volume of the pool, there's two ways I could do this. I could split it up into two shapes in volume and calculate the volume separately, but I think it's easy to just do it by area. So if I draw a line from here all the way along to here, I'll have a rectangle, and then I'll have a little triangle. So let me draw that out for you. I've got the rectangle first. Dimensions of that are 0.5 on this side, and the whole length is 16. And then I've got this triangle. Now you need to be careful with this bit. It is a right angle triangle. Its height is 2, but is it? Because that's an immediate thing you would think to do, because you look at it and go, oh, I see 2, so I write 2. But look, I've cut it here. So there's this little bit that I need to take off, 0.5. So watch out for that. I actually need to do 2 minus 0.5, which is 1.5. Similarly, going along the way, I'm not going all the way along. I'm stopping here, which is 4 short. So it's 16 minus 4, which is 12. And now I can do the area of both bits, and once I do that, I'll know the area of the whole front bit here. And to get the volume of a prism, you just times by the depth. So let's do our area. 16 times 0.5 plus a half of 12 times 1.5, because the area of a triangle is half the base times the height. So 16 times 0.5 is 8 plus a half, which is 0.5 times 12 times, and it was 1.5 height, not 2, which is 9. 8 plus 9 is 17 square metres. Then we know our depth is going in this way, which is the same as this one, so it's 8. So our volume is 17 by 8, which is 136 metres cubed. But that's not litres. So there's a few conversions you need to know for National 5 apps. You need to know that 1 centimetre cubed is 1 millilitre. And it's worth knowing, but you can work this out yourself, that 1 metre cubed is 1,000 litres. Now, how could you get there yourself, you're wondering? Well, 1 centimetre cubed is 1 millilitre. So that means that 100 centimetre cubed equals 100 millilitres. So what about 1 metre cubed? Well, that is 100 times 100 times 100, because it's 100 by 100 by 100 centimetres. So that would give you 100 times 100 times 100 millilitres, and then just divide by 1,000 to get in litres. Although it's just much quicker and easier, if you ask me, to remember that 1 metre cubed is 1,000 litres, because it comes up more often than not. So I'm just going to use that. 136 times 1,000, 136,000 litres. And we're done there.
Clubs set up a course at the event. Participants leave the start point and run on a bearing of 55 degrees for 140 metres to A. They then run on a bearing of 170 for 252 to B. Construct a scale drawing to illustrate this route. And it says use the scale 1 centimetre is 40 metres. So we know that for now, and we'll work out our angles first. So we need a protractor for this. Okay, so I've got a protractor set up, and it says we leave the start point and run a bearing of 055 degrees. So if I go back down here, I've set up a north line, and you have a protractor going up through the north line, going to the right, and I make sure that that line goes through the 0, so it's the outside scale, and I measure around 55 degrees, which is around to here, so I put a little mark there at 55. So it says 140 metres, but 1 centimetre is 40 metres. So I need to do 140 divided by 40 to see how many centimetres I need. So that's 3.5 centimetres. So I'm going to bring my ruler in, join it up through the dot from this centre, and we'll draw 3.5 centimetres. My ruler lined up as best I can on an iPad. It'll be much easier for you. Forget about the angle on the ruler. That's just the thing on the ruler on this. So I'm at 0, and I want to draw 3.5. So up to here. That looks good. Get rid of his ruler. Get rid of that extra mark. And there we are. So now we've got to here, so we need a new north point. So we draw another north line in using a ruler. And then we check the next bit of information. 170 degrees to flag B. Once again, I bring my protractor and line it up completely. This doesn't go past 180, so I'm good. So I just measure down to 170, which is here, and put a little mark on the 0 down to 170. And then I take my protractor away and join it up with a ruler. So now for this bit, it says 252 metres. So again, I do 252 up here, divide by 40 to see how much I need to draw. That is 6.3, so 6.3 centimetres. So I've lined up my rule as best I can. Obviously, it'll be much easier for you with pen and paper. I have to go to 6.3, so I can see here that I've got 6.123 down there. So being very accurate as I possibly can, 1, 2, 3. And joining it up. I'll take away that ruler. To continue this question, it says if pupils then return to the start point, use the scale drawing to determine the bearing and distance from the start point to flag B. From flag B. So there's our drawing. So all I need to do is get a ruler and join up the points. So to work out the distance, I get my ruler to measure the distance. Being as accurate as I can, I get 4.4. 4.3 or 4.4. So 4.4 I'll use, and it's 40 per metre, 40 metres. 4.4 times 40 is 176 metres. Not kilometres. Don't know why I got kilometres on my diagram, but I'm not going to change it now. We'll just change it here. There you go. Metres and metres. Okay. And I need the bearing. So from B, so I'll draw an off line. Use a ruler for that. And I want to go all the way around to the start. So if you watch my trace here, I'm going all the way around to here. So I actually need to extend my north line underneath because it's past 180. When it does go past 180, you get your protractor and extend your north line. If you've not got a protractor that goes all the way around, which a lot of us won't, and you go down through that line from the middle, making sure it's all lined up, and you measure around on the inside scale this time. No, it's not the outside scale actually. So it's round to here. So let me just count that by zooming in. We've got 130, 135, 36, 37, 38. 138, I take that as. So let's go back to the question. So it's 138 degrees, but plus the 180, which gives us a bearing of 318 degrees. So 176 metres.
National 5 Applications of Maths 2023 Paper 1 Question 2. A lorry speedometer is shown. The lorry speedometer is restricted to a maximum of 56 miles per hour. Use the speedometer to calculate this speed in kilometres per hour. Okay, so let's have a look at this. Miles per hour is on the outside. Kilometres per hour is on the inside. So I need to find 56. Well, let's see if it's going up. Always check if it's going up in ones or not. So it goes up in ones on here. But on the inside, you should be able to see it goes 0, then 20, and there's only 10 in between. So it's actually going up in twos. There's 10 in the middle. So be very careful there. Now let's try and find 56. So we'll zoom this right in. Miles per hour, 55, 56. So there's my 56 here. Taking that straight across, you could have used a ruler for this, but I can do it quite like that. It's going to be right there. So I just need to count the kilometres per hour. Remember, this is going up in twos. So it's 82, 84, 86, 88, 90. We get 90 kilometres per hour. Usually a mark for marking it on the diagram and then just for reading it off.
Gillian thinks that 24 degrees F is colder than minus 3 degrees C. A thermometer is shown. Determine if she is correct. So we just need to find these numbers on here. There's F on this side. So finding 24, well, there's 20, and then it goes 1, 2, 3, 4, 5. So it's going up in twos, 22, 24. So let's mark 24 on this diagram. I'll make that nice and big. There's 24 degrees F. Now we have to find minus 3 degrees C, which is this side. So again, there's 0, and we're going down the minuses. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So that's going down on ones. So minus 1, minus 2, minus 3. There is minus 3 degrees C there. She thinks Minus, right, 24F is colder than minus 3, so it has to be below it. Is she correct? Yes. 24 degrees F is lower than 3 degrees C on the scale, would be enough to get your mark.
This way, National 5 Applications to Maths 2023, Paper 1, Question 10. John owns a bike shop and has a team of mathematics. John owns a bike shop and has a team of mechanics to build each new bike. The table lists the tasks that need to be completed, so we've got a precedence table to complete. Complete the diagram below showing by writing these tasks and the times in the boxes. So we've got the first one of them's already been done for us, D and 2. So there's our D, which is 2 minutes. And before D, we've got G, H, I, and J. So G, H, I, and J could go in these boxes, and we kind of need to work from there. But I'm going to find our first one first, because I always work from the start. Our first task is F, because it's got no preceding task, and F has got a time of 2 minutes. So I can write F and 2 in this first box here, because that's our first task. Now, after F, we have got this one, and that's it, 2 tasks. So the easiest way to do this is trial and error. Try it one way. If it doesn't work, just go back and try again. So let's just try it one way. After F, we could have attached bicycle to bike clamp stand. That's A for 1 minute. And then, just knock that one off. Looking at A, after A, we could have B and C and H. Well, I've not got enough space now in that place, so I can just delete that A and go, look, I need 3 places to happen. So I need to, if I go here, I'm not going to be able to do it. Here, I'm going to have to go this way. So there you go, A has to go in there. So deleting that, I can put my A and 1 in here and go back up to where A was. And then we've got B, C, and H comes after A. So again, I'll just put them in anywhere. B, C, and H. Taking a note of our numbers, 1, 7, and 5. Then I'll just check what comes after B. So B, C, and H is done. After B, we have got J. So we could put J here. And J is 3. And after J, let's hope it's D. Yes, it is. So that one's in the right place. Or it could go that way. It doesn't really matter now. After C, looking down this list, we've got inflate tires for 4 minutes. So we've got I takes 4 minutes. And just check after I, we go back to D, because if not, we need to do something else. After I, we go back to D, so that's okay. And then check H. What comes after H? It's D, so that one's okay as well. So now we can go back to this branch and complete. After F is E, that is 1 minute. So I can put E in 1. And after E is G for 1 minute. So I can put G in 1 and just double check that after G, we go back to D, which we do here. So we've done that one. So we've completed our table. John thinks that the table mechanics will have a big grade in 50 minutes. Is he correct? Well, how you do these precedence tables is you start at the start. So I've got task 2 minutes. And then it's the longest of these 2, which is 1 minute. So add 1 minute. And then when I move on, I need to wait until the longest of these is finished. So that's 7 minutes. So 7 minutes. And then it's the longest of these 2, that's 4 minutes. And then it's 2 minutes at the end. So that's the critical path, we call that. 7 plus 3 is 3, 2 plus 3 is 1, plus 7 is 10, plus 4 is 14, plus 2 is 16 minutes is the minimum time John is wrong since 16 is bigger than 15. And we're done there. SQA National 5 Applications to Maths 2023, Paper 1, Question 7. Biscuits are sold in tins in the shape of a cuboid as shown. The tins need to be packed into boxes with the lid facing upwards. There are two types of boxes available with the dimensions shown, box A and B. Calculate the maximum number of tins going to be packed. Use working to justify your answer. This is actually a simplified version of a box packing because usually you can take your container and just move it around in different positions. But in this case, since this box is the same on the length and the breadth, it doesn't matter whether I turn that around, it's going to be the same either way. I need to keep that lid facing up. So really all I need to do is work out how many of these go in this box and how many of these go into that box, and then just pick the best box. There's only one option for each. So let's look at box A. So our dimensions are 10, 10 and 15, 42, 51 and 50. So we've got 42 centimetres on one side, that's the length, the breadth is 51, and the height is 50. And we need to know that the length and the breadth need to go along the length and the breadth because the box it needs to be facing up the way, so the height needs to match the height. But 10 and 10 is the only options. And then we've got 15 height, so our 15 matches this one. So this is a big box, I suppose, and this is a small box. And then we've got 10 matches this one and 10 matches this one. So once we've worked out which sides go with which sides, we just divide them. So 42 divided by 10, but only whole number answers, you can't go above. So just do 10, 20, 30, 40. That equals about 4. Notice the little tiddles means about, right? And then 51 divided by 10, that's about 5. 5 tens are 50 with one remainder. And then 15 into 50, 15, 30, 45. It's going to be 3 and a bit. So 50 divided by 15 approximately is 3. So in total, remember we just times our answers together. 4 times 5 times 3. 20 times 3 is 60. So I can get 60 in box A. Now I need to do box B. Box B is exactly the same. So for box B, I always like to set it up as a table. My big box against my small box. Our length, breadth and height. So again, length, breadth and height. So this time the length of this one, depends what you call the length, but I use that, so 45. The other side is 72, and this time the height is 32. And again, we need to have against the height our 15 centimetres because it has to face up the way. And then the 10 centimetres need to go against the other ones. So doing our sums, we get 45 this time divided by 10, which is about 10, 20, 30, 44. I'll use little tiddles. Then we've got 72 divided by 10, which is about 7. 7 tens are 70. And then we've got 32 divided by 15. 15, 30, that's about 2. So our total for this box is equal to 4 times 7 times 2. 4 sevens are 28, times 2 is 56. So determine the maximum number of boxes to be packed. Max is equal to 60 in box A. SQA National 5 Applications of Maths 2023, Paper 2, Question 6. Lorna was travelling around Europe. She converted £640 into Polish zlotys. I hope that's right. She was in Poland for 4 days. She spent 340 Polish zlotys each day she was in Poland, and then she converted her Polish zlotys into euros. How many euros did she receive? I hate these questions, they're so silly. If you were in Poland, right? and you're going to change it into zlotys, you wouldn't change it back to pounds first. You would just get told how much it's worth. But for these questions, you're not told what a zloty is worth in euros. So you're going to have to go back to pounds and then back to euros. That's how these questions work. So let's do it bit by bit by bit. Lorna converted £640 into Polish zlotys. Let's do that one first. 640 times. And the exchange rate for zlotys is 4.94. So I can just get my calculator out and write down whatever that is. $3,161.6. So 0.60, because we'll just assume that every currency is decimal. Let's just write zlotys. Okay, next one. She was in Poland for 4 days and she spent 340 Polish zlotys each day she was in Poland. So she spent 4 times 340. Which is 1,360 zlotys. And then says she converted the rest into euros. So I now need to work out how much she's got left. So left is 3,161.60 minus 1,360, which equals 1,801.60. Make sure you put two decimal places, okay? Money. Zlotys. So that's what she's got left. And now we want to change it back into euros. So if we go back to our table, we're on zlotys. We can't get to euros. We need to go back to pounds. So divide, once you're at pounds, times by the euros. The thing I need to do, first of all, is 1,801.60 divided by our 4.94. That gives me 364 point, now notice it says 696, so 70, that's in pounds. And then to change it to euros, 364.70 times that exchange rate of 1.15. Which equals 419.405. So 41 euros. Now, if you did this sum, and I did it earlier, as one go, divide then times straight away, you actually get 419.40 because it will not round twice. I've got a feeling you need to round twice because you changed it, then changed it. So I will. £1,052 per week. National insurance calculated before deductions. Calculate Lynn's national insurance payment. Right. So up to £242, you don't pay anything. Then between these two numbers, you pay 13.2%, and then above this number, you pay 3.25%. So I need to work them all out individually. So Lynn earns £10.52. So for the upper bracket, I take away £9.67 to see how much she pays at 3.2%. That's 85 for upper. And then for your mid part, I just need to take away these two numbers from each other. 967 minus 242. Which is 725. And then on the rest, you pay nothing, so you just don't need to do anything. So now we can work out the national insurance. So for the upper part, we have got over 967 is 3.25%. So 3.25% of 85. Getting a calculator out, that is 3.25 divided by 100 times 85, 2.7625. Two decimal places, £2.76. Now we do the same for the mid. So our mid one is 725 and 13.25%. So 13.25% of 725 get our calculator for that. 13.25 divided by 100 times 725 is 96.06. 96.06. So adding these together to get the full national insurance. So adding them together, our total national insurance, £2.76 plus 96.06, 2.76 plus 96.06 is £98.82. Okay, next question. Lynn pays 4.5% of her wage into our pension and our income tax is 5208. Find the net pay. So for our pension, we need to work out 4.5% of her weekly wage, which was 1052. So using a calculator for that, 4.5 divided by 100 times 1052 is 4734. And then we need to work out her net pay. So we take her full pay, which is 1052, minus everything that we need to take off. So the 98.82. That's the national insurance. The tax is 5208. And the pension is £47.34. So we'll just get our calculator and work all of that out. 1052 minus 98.82 minus 52.08 and minus £47.34, and we get 853.76. And we're done there. H3 National 5 Maths 2023 Paper 1 Question 1. Josh earns £9 per hour and works 30 hours per week. His weekly outdoors are £220. This is always remaining money. He books a holiday for £566. He will take £800 spending money with him. Calculate the minimum number of weeks it will take him to save this amount. Okay, so he earns, let's just go through this, £9 per hour, 30 hours per week. So we need to work out his weekly wage. So weekly wage equals 30 times 9, well 9 for these is 27, so that's £270. But then his outgoings are £220 a week, so what he's got left per week is equal to 270 minus 220. Again, there's no need for a sum here, just count out 30, 40, 50, 60, 70, £50 is what he's got left per week. It now says Joe saves all of this, so he saved £50 per week, and he books a holiday costing $566, and he needs £800 spending money. So I need to know how much he needs. So for the holiday, he needs. Now I will do a sum just to be in 566 plus 800. Well, that's pretty easy. 800, 9, 10, 11, 12, 1300, so 1366. So calculate the minimum number of weeks it will take him to save the amount. You need to do 1366 divided by 50. So you can do that by counting in 50s if you want, or do a sum. I think the easiest way to say it is 1 week is equal to £50. That means 2 weeks is equal to £100. So I need to get up to £1,300, so I need to times that by 13. So times them by 13 weeks will give me 26 weeks. Will be £1,300. So then 27 weeks you can obviously see is 1,350, and 28 weeks he will have £1,400, and he needs 1,366, so it will take him 28 weeks. Obviously, you could have just directly divided 1366 by 50, and you would have got 27 point something, which is rounded into 28 weeks. Basically, National 5 Application of Maths 2023, Paper 2, Question 7. Dave has a job in an office typing documents. He is contracted to work 35 hours per week. He earns £11.20 per hour. He's paid time and a half. for overtime. Last week he worked 37.5 hours. What is his gross pay? The pay before deductions. Okay, just his pay. So he works 35 hours normally. So his normal pay is 35 times his £11.20. Then we need to add on whatever he gets at time and a half. So I need to work out the difference between 37.5 and 35, which is 2.5 hours. So he's getting 2.5 times his £11.20 still, but at time and a half means times by 1.5. You can do the two sums separately if you feel you want to, or brackets lets us do it in one. Brackets 35 times £11.20 plus brackets 2.5 times £11.20 times time and a half of 1.5 is £434 exactly. And that's part A. Scatter graphs, SQA National 5 Apps, 2021 Paper 1 Question 2. Elephants continue to grow for the duration of their lives. The table shows the sample of elephants and their shoulder heights. On the grid, draw a scatter graph. So a scatter graph's just plot the points, go along the X, up the Y, be very careful. So let's just do that in bits. So the first one is 12, 1. Let's look at our scale first, actually. So it goes up in ones on the side. I can see that by counting the boxes, but up the side, it goes up in tens, 10, 20, 30, 40, 50, up to 100. So I need to be very careful when I'm plotting this. So the first one is 12 to 30. So I'll go to 12, up to 200, and then 10, 20, 30. So I'm going to plot this on now. I'm on 10, 11, 12, 10, 20, 30. There's my first dot. The next one is 17 to 50. So 17, 2 after 15, straight up. I'm at 200 and then up to 250. It's in the middle of 200 and 300. I quite double check before I mark it, and I'm fine with that. 28 to 70. So 25, 26, 27, 28. Straight on that line, up to 250, 260, 270. That'll be there. So that's 28 and 270, 35 and 275. So 35 is nice, straight along. 35, 200, 250, 260, 270, 275 would be right in the middle, so about there. And then the last one, 43 and 300. So 43 all the way up to 300, so 41, 2, 3, and I'm on the 300 line, so there we are there. And then we get a nice scatter graph. Draw a line of best fit, so we need a ruler for that. Line of best fit is when you put it so it lines up as many points as you can, or at least that kind of equidistant, straight distance away. Best you can, that will probably do. And then just neatly drawing your line in. And there's quite a bit of leeway with a line of best fit, so don't worry if you're a little bit off. The last bit says use your line to estimate the age of an African elephant is 260. So I'm going to zoom in again to see where 260 is. There's 260 there. So if I can get a ruler or just draw a straight line, I'm just going to draw it without a ruler so you can see it because it tabs it. You use a ruler to get that line, and then you just go along to the line and straight down to where it meets the other axis. So in this case, I can just go straight down there. And I'm sitting about 21, but you might be plus or minus a few depending on how your line of best fit is drawn. But I'm going to write 21 for my line. And I'm done there. So the 8 newborn babies are recorded in the table as shown below. So here's the table, and then on the grid, draw a scatter graph to show this data. So for part C, we have to draw a scatter graph. So remember that just means weight, check where that is, up the side, length must be down the bottom, and I'm just plotting points the best I can. So 2.7 and 46, 2.7, well, it's going up in ones, so that's 2.7 there. So I'll just put a little dot, tick it off as I go, then 47 and 2.8. So there's 47, 2.7, 2.8, tick it off. 49 and 3.5. So there's 49, 3.5 will be here. Tick it off as I go. 51 and 3.7. So I go to 51 and I go up to 3.567, making sure I'm being as accurate as I can, taking my time. 52, 3.4, 52, and 3.4 will be there. 52 again, but this time 3.7. So on the same line, 3.5, 6, 7. There it is there. 54 and 4, 0.0. So 54 is the second last one. So there's 4.0 right there. And the last one, 55 and 5.4.4. 55 is the last place. 4.4, 1, 2, 3, 4. And we get a completed scatter graph like so. Part 2, draw a line of best fit on your scatter graph. So I'm going to need the ruler for this. So there's my scatter graph, and it can't go through every single point. So I'll just make it so that at the very best, I get the points are equal distance away from the ruler line either side. That's a good line. It doesn't have to be exact, and it doesn't have to go through that first point. If it doesn't, it doesn't. If it does, it does. I'm going to say about there, maybe a little bit more, is a good line of best fit. And I'll just draw my line in nice and neat. And you get a line of best fit. Either, as long as it doesn't join the dots and it isn't obviously way off, you'll get the marks for this. Use your line to estimate the weight of a baby who was 50 centimetres when born. So I need to find 50 centimetres. So let me just make that a little bit neater. So I can do this showing you by highlighting this 50. I go up to where it joins the line and then read off the mark. Now the best thing to do is actually get a pen, different colour, and literally get a ruler and join that up. Now I can do that without any bother, and then do the same on this side. And you can get a nice close enough answer of 3.123. So I write 3.3 and the answer's in kilograms. And we're done there for the scatter. Screen National 5 Application Maths 2023, Paper 2, Question 5. Stuart records the chlorine levels in his hot tub. I do that every day. A sample of the levels is shown below. For these levels, calculate the mean, then standard deviation. Okay, standard stuff here. To calculate the mean, you add them up, divide by how many there are. So let's write down the sum we need to do. Always write down sums that you're doing, even if you're using a calculator. 0.8 plus 1.9 plus 1.1 plus 2.6 plus 3.1 plus 2.4 plus 2.1 in brackets, because I'm then dividing all of that by 7 because there's 7 days. So calculator, take full advantage of this calculator. 0.8 plus 1.9 plus 1.1 plus 2.6 plus 3.1 plus 2.4 and the last one plus 2.1. If I'd use brackets, I would just put it in brackets. I'll just press equals and then divide by 7. I get 2. Units are not usually required for the mean, but it doesn't even give us units anyway. So there we go. Calculate the standard deviation. From the start of the exam paper, there's 2 ways to calculate standard deviation. I'm going to show you one of them. So the formula I use is for the standard deviation is the square root of the sum of x minus x bar squared over n minus 1. But there is another more complicated formula, I feel, so I always use this one. Now, x bar stands for the mean. So I'm doing every number, take away the mean, squared, add them all up, divide by how many I've got. Nice little table to illustrate this. So I usually just draw a 3-bit table here. X goes here, that's all my numbers. X minus x bar, which is the top of the formula, take away the mean, and then x minus x bar squared. And at the end, you get a nice total down here somewhere. And it's this total that goes in the whole of the top of the formula. And then you divide by 1 less than the number of numbers you've got and square root the answer. So let's write down our numbers, 0.8, 1.9. And then we've got 1.1, 2.6. And then we've got 3.1, 2.4. And finally, our last one was 2.1. Be very careful you don't miss any of these. I'm just going to delete this little bit that I added so I can work. Okay, x minus x bar. Now you don't really need to write down the sum you're going to do, but I'll do the first one. Our x bar was 2, so we do 0.8 minus 2. Don't worry, we get negative numbers here. You're going to get negatives. Minus 1.2. 1.9 minus 2. Minus 0.1. 1.1 minus 2. Minus 0.9. 2.6 minus 2. 0.6. 3.1 minus 2. 1.1. 2.4 minus 2. 0.4. 2.1 minus 2. 0.1. The negatives are fine because look, when you put a negative in a calculator and square it, you get a positive answer. Just put brackets around it. Let me show you. Bracket minus 1.2, close the bracket. Press squared. Oh look, it's a positive number. Now, you can just drop a negative when you square it in the calculator, just put 1.2 squared. So I'm going to do it for all of these numbers. So I've got 1.44, 0.1 squared, 0.01, 0.9 squared, 0.81, 0.6 squared, 0.36, 1.1 squared, 1.21, 0.4 squared is 0.16, and 0.1 squared I've already done is 0.01. So now I add all these up to get a grand total. 1.44 plus 0.01 plus 0.81 plus 0.36 plus 1.21 plus 0.16 plus 0.01. We get 4. Rather unlikely, but there we are. So that means we can work out our standard deviation. Our standard deviation is simply the square root of 4, because we just worked that out, divided by 1 less than the number of numbers we started with, which is 6, because we started with 7. None of this is non-calculator, so I'm not even going to bother simplifying that. Square root of, make a bracket, 4 divided by 6, close the bracket, 0.81649, 0.81649. Round that to a better degree of accuracy. Really should be 1 decimal place, but I'll put 2 just in case. Let's call that 0.82. And we're done there. His friend Colin's hot tub had a mean of 2.2 and a standard deviation of 1.4. Make 2 valid comparisons about the cloning levels in Stuart and Colin's hot tubs. Well, let's look at our answers again. We got 2 and 0.82. So for Stuart, we had a mean of 2 and a standard deviation of 0.82. And then we can just work on this. His friend Colin had a mean, so let's compare the means first, 2.2 and 2. So comparing the mean, you always use the word on average. On average, the chlorine levels in, well, Colin's is higher. Colin's hot tub are greater than Stuart's, since 2.2 is bigger than 2. And there you go. There's a mark. Now let's compare the standard deviation. Standard deviation is about how variable the levels are. So Stuart's was 0.82, Colin's is 1.4, so Colin's chlorine levels are more varied. So Colin's chlorine levels are more varied than Stuart's. I suppose in the hot tub, not actually the people, but you'll be fine with that. I'll just do it for the sake of clarity. Now we can just write since, again, the idea here is 1.4 is bigger than 0.82. I always just remember one statement, really, bigger. The number of words per minute he typed during a 14-minute period with to calculate the medians and the lower and upper quartiles. Remember, for median, you need them in order from smallest to biggest, so be careful doing that. Let's do this now. The smallest number I think is 37. So let me write 37, and I think that appears twice. So 37 and 37. If I miss any, I do apologise. 39 is next. And then I can see we're in the 40s now. The lowest is 42. And then we get two 44s. 42, 44, 44. And then I'm pretty sure we're getting 40. Oh, I missed 41. See, you always miss some. So let's put that in between 39 and 42. It's 41. Then there's 46, 47, 48. That was two 47s as well. Cross them off as I go so I can keep track. Then I've got a 49. And then I'm going to run out of space, but it's fine. 51, 54. There we go, we can see that, can't we? Okay, so there's all my numbers. So now the median is the one in the middle when you put them in order. So I need to find the middle. A few ways to do it. You can cross off top and bottom as you go, which I will just do, but I won't cross them off. Actually, I'll just note them. Top and bottom, top and bottom, top and bottom, bottom and top, bottom and top, bottom and top. Ah, there's two in the middle. There's these two here. So the median's in the middle of these two, between 44 and 46. That should be obviously 45, but if you don't know that, add them up to 5 by 2. So now we want to find our quartiles. Just delete that little thing for clarity. So our quartiles, remember, are the middle of the first half and the middle of the second half. So I've got 1, 2, 3, 4, 5, 6, 7. So I'll go 1, 2, 3, 1, 2, 3. There's our quartile there. So I'll just note that. That's quartile 1. Similarly, on the other side, that one must be quartile 3. Just check. 1, 2, 3, 1, 2, 3. Yep, yep. And then just to answer the question in words, so our median is equal to 45. Our quartile 3 is equal to 48. And our quartile 1 is equal to 41. Words per minute, I suppose you could write, but we'll just leave it there. Construct a box plot for this set of data. Box plot, right. So how box plots work, remember, is your quartiles go on the ends of your boxes, your median inside the box, and then your highest and lowest numbers at the end. So let's do where's our highest and lowest numbers? Our lowest is 37, our highest is 54. Lowest is 37, highest is 54. Okay, there's our picture. It does go up in ones, but double check it. So 35, 36, 37. I've got 37 right here. So that's my position. I'll just put a little dot now, and then 54, 50, 51, 2, 3, 4. Being very careful to be accurate. So there's my start and end positions on the box. And then my quartiles, 41 and 48. So 40 is here, so 41, that's where my box starts. And 48, 45, 46, 47, 48, that's where my box ends. And you really should be using a ruler, but I will just do it. I can get straight lines on this, but you should be using a ruler. 41 and 48. Connecting that box up, connecting that up to our start and end points. And then putting our median in, which we can put that lines there for clarity. Our median was, remember, 45. So I'm on 40, 41, 2, 3, 4, 5, which is right there. We can note these things. So that's our lowest, highest, median, quartile 1, quartile 3. But you should probably get away with just drawing the box and you'll be fine. Calculate the interquartile range for the number of words. The interquartile range, remember, is simply quartile 3 minus quartile 1, which we've already got twice now. So quartile 3, 48 minus 41. 48 minus 41, 7. So 7 words per min. Lynn works in the same office as Dave. Lynn also records the number of words per minute she can type. the interquartile range for number was at Lincoln type per minute is 5. Make a valid comment. Like interquartile range is how spread out the data is. It's pretty much the same as standard deviation, same comment. So it's about how varied they are. Okay, so Lynn is 5, Dave was 7. The number of words Dave types per minute is more varied than Lynn's, since 7 is bigger than 5. Done. A SQA National 5 Application Maths 2023 Paper 1 Question 11. A survey was conducted in favourite pie phones. The results were 80 for apple, 40 for cherry, and 60 for lemon. Construct a pie chart to illustrate this information. So to construct a pie chart, we need a protractor. But first of all, we need to calculate our angles. So to calculate your angles, it's each individual, we need to do the fraction of a circle. So it's 80 out of the total times 360, because it's 360 degrees in a circle. So our total, if I just put it at the bottom here, is 80, 120, 130, 40, 50, 60, 70, 80, which is handy because 180 goes into 360. So the fraction for the first one is 80 out of 180 and times the 360 for the angle. So you can do this division first, which is 2 times 180. You can do this division first, which is 2 times your 80, which is 160 degrees. Similarly for this one, 40 out of 180 times 360. Well, 360 divided by 180 is 2 times 40 is 80 degrees. And your last one, 60 out of 180 times 360. 60 divided by 180 is 2 times 60 is 120 degrees. Just double check that these three numbers add up to 360. So we've got 120, 200, 360, so chances are you're okay. So now you get your protractor and start filling this in. So I've got my protractor, so now we turn that around so that it's vertical. We make sure the middle goes on the dot, and we make sure it's lined up through the zero as best you can. Now mine won't be as accurate as yours can be because I'm using electronics. But the first angle I want to draw is 160 degrees. So there's my protractor. It's going through the outside scale. So go all the way around to 160, which is way down here. And I make a little mark at that point. I then get rid of my protractor. And we get a ruler and join this up. I don't need a ruler on my pad. I can just make a straight line by joining it. So let me just get it back to this normal size. It's going to go to there. And then I can just adjust it and make sure it fits. And we're done there. Let's just double check that angle before we move on. 160, we're done. Well done. Let's move on to our next angle. Next angle is 80 degrees. So what we do is we get our protractor. We turn it around so that it's lined up against our new line. So putting that in the middle, lining it nice and up as best you can, pushing it up. A fine adjustment, good enough for me. And then we're looking for 80, so I'll zoom in. We're still going through the bottom scale. So zooming in, going all the way down to 80, which is over here, and moving it out of the way, and getting your straight line and your ruler, joining it up through that zero, making sure it's nice and neat to the end. And again, always double check, have you done an 80 degree? So my protractor on the middle. Yep, it's going 80, so we're good there. And now we can just measure our last angle to make sure that it actually is 120. It should be if you've done everything accurately, but a double check is always handy. Turn it around so it's going through our new line, line it up. Slightly off, but I'll take that because then I'm doing that on an iPad. And you just try to be as accurate as you possibly can to get this. You can see it's pretty much bang on. So there we are. We can then just label our pie chart. So let me get rid of this. So the first one we drew was our apple. So I'll label the angle just to be very clear. The angle I drew was 160, 160 degrees. That's apple. And that represents 80 people. Our next one we drew was cherry, which was 80 degrees. So there's 80 degrees. That's cherry. And that represents 40 people. And the last one we drew was lemon, which represents 60 people. And the angle we used was 120, which is in here. And I'll just put our total people at the side. You probably won't need this, but just to be very, very safe, 180. And we've constructed a pie chart.
Maths 2019, Paper 1, Question 3. The pie chart shows the number of hours overtime at 72 employees of a supermarket worked during 1 month. Calculate how many employees worked 15 plus hours overtime. So let's have a look to see where that is. If we look at here, there's our 15 plus hours there. That represents 30 degrees. So we know that 30 degrees out of the total 360 degrees of, and it's 72 employees. So we're trying to do a sum like this. We might as well simplify the fraction to make it easier. So that equals, taking the zeros off, 3 out of 36 of 72. 3 into 36, well 3 goes into 36 12 times, so that's 1/12 of 72. So counting in 12s, 12, 24, 36, 48, 60, 72 equals 6. 6 employees worked 15 plus hours overtime. The probability that an employee chosen at random worked 9 or less hours. So 9 or less hours means this segment here and this segment here. So we've got 180 degrees, that's half of them. So we need to work out how many people that is. Half of 72 is 36. Now we don't know how big this bit is, so we need to work that out. So let's add up all our angles that we've got. We've got 180, we've got 30, we've got 90. So that's leaving 9, 10, 11, 12, 20, 3, 60 degrees this bit. Now we've already worked out 30 degrees, that was 6 people. So if 30 degrees is 6 people, 60 degrees must be double that, so that's 12 people. So the total number of people, 36 plus 12, out of the total number in people in total, which is 72. So 36, 46, 48 out of 72 is our probability. But then we need to simplify all fractions. So let's half the numbers first, 24 and 36. Half them again. That's 12 and 18. Oh, I could keep halving. That is 6 and 9. And now I can't half, but 3 goes into both of them. 3 into 6 goes 2. 3 into 3 goes 9. 2/3 is the probability. You could have got there quicker if you picked a different number.